Okay. All right, guys. So there is a question, right? Oh, wait. Sorry, I forgot to share my screen. All right. Can you guys see my screen right now? Okay, good. All right. So okay, this is your second lab, right? So what I'm going to okay, there's a question regarding that what's that? If you guys have multiple codes, right, in one project, when you guys have only one code, for an example here, I only have lab2.v, right? Then I save it, then I try to compile it, no problem, right? Everything works fine. But then I create another file, right? Let's say I name it as lab3.v. Then I create another one, lab4.v, right? So I have three files in one project. Then I'll try to compile it. Of course, it is going to give me error, right? So if you guys remember, previously I've talked about so previously I've talked about top level module, right? So top level module. So the concept is that if you have a multiple codes in one project, it has to be connected to each other. So if you have three independent codes, let's say, I mean, this is memory code, right? And then you have another one, for example, it is ALU, arithmetic logic unit code. But those two codes have no relation, right? So it's not connecting each other. So what's going to happen when you compile it, right, is going to give you error. All right, so if you want to have multiple code, you have to create a new project. You have to create a new project, or the other way, if you don't want to create a new project, you just go to file tab here, then you right click, then you can remove it from file project, so that when it compile, it won't go and look into your file, your lab2.v file. All right, so that's the explanation of to the question that why when you have multiple code or multiple .v files in one project, when you compile it, it gives you error because, right, one project needs to have one top level module. If you have multiple codes, all the codes need to be connected to each other. Mainly, it has to be connected to the top level module, right? So the top level module code is the main code, right? So inside the top level module code gonna be the small code inside it, right? So but everything has to be connected to the top level module, right? Can you get, do you guys, can you get my explanation, guys? Is it okay, Farisha?
Not make sure. Maknanya saya kena tutup dululah file yang previous yang asing-asing tu.
Okay, there are two options, right? Okay, there are two options. The first one, each file, I'm answering your answer in English, right? Because there's an international student here. All right, so I mean, like that, we have we need, if we have multiple files, so your option is that you need to create a new project for every file. And let's say you want to create, okay, you done this part, right? So you want to try another file, so you just new file, and then go to new project wizard, right? So it's gonna ask you to close this project lab 2 and create a new one, right? So this is one option. Another option is that, I mean, you do multiple files, but you remove it. So you remove it from your project. So you don't want to compile lab 2, you remove it. Okay, let me show you an example here, right? So I have, let's say I create another file, right? So it's a verilog file. Okay. Okay, then desktop whatsoever, then I save it, right? So I save it, I name it as lab3.v. Okay, so when I compile it, so you see what happened when I compile it, right? So let's see this one, just save it. So let me compile it. So automatically it's gonna give me error, right? Because when we compile it, it's going to compile all the files within the project. Okay, so what I'm going to do here, so okay, let's say I don't want to compile lab3.v because I just want to do lab2.v. So what I'm going to do here, so I just go to my files tab, go to lab3.v, right click, and then remove file from project. Right, so now I'll try to compile again. Let's see if I got that. Still receive the error. Okay, see now I don't get any error. Right, because I just compile whatever file that I want to see. Right, okay. So I hope you guys get the explanation. Okay guys, any more question before we go into the next session? Asking you guys to share your screen. Okay, what about it? Okay, go ahead.
Sir, do you see my screen?
Yes, I see it. Wait, let me put it here.
Now here I was trying to open a new project, but it show this window here. So I don't know what the problem is.
What is it? You must have device support installed before you can open the project to download device support. Okay, when you do the installation, right? So I'm seeing that you are installing Quartz Prime, right? So which version is this? Is this the 20.1, the one that I shared?
I was click on the link you're given. It's 18.1 light version.
Okay, all right. Okay, guys. So
Right.
what I'm telling you guys. So I've shared with you guys two version, right? So I think it's gonna be easier if you guys use the 13.1. The 20.1 is one of the latest one, Quarters Night, right? But it's okay. I mean, it is almost the same. So better use the 13.11, the one that I've shared with you guys. Okay, but that error is because of when you do the installation, you have to tick, right? So there gonna be options, right? Which device that you want to install together. So I've explained previously, there are a lot of families, right? There are a lot of devices in provided by Intel. So you have to choose. I mean, it's better just to choose all. Cyclone 2, Cyclone 4, yeah, whatsoever family, just take it, right? So right now, what happened is that you don't have any devices installed together with your Quarters. So when you want to work on the project, right? So I mean, which device that you want to work on, there are no options in it. Are you getting me, Kim Hui?
Yes, understand.
Okay, all right. So what you need to do, you have to repeat your installation, reinstall it.
Okay.
Okay, all right. Okay, guys, any more question? Any more question, guys? Okay, all right. So if no question, all right. If no question, then any of you want to volunteer first? So what you have done last week. If no volunteer, I'm gonna start to pick a name. All right. Okay. No volunteer. Okay. Let's choose right. Okay. Let's go. Okay. Ahmad Nazrin. Ahmad Nazrin bin apa? Ahmad Nazrin. I think just only one Ahmad Nazrin in this lab, right? Yeah, Ahmad Nazrin, are you there? Still alive?
Yes, sir.
Okay, go ahead, share your screen, show me what you have done. Ahmad Nazrin, are you ready?
Saya baru lepas install. Sekejap.
Okay.
Baru sebenarnya problem baru selesai.
Alright. I've told you guys, right? I mean, it's not now, right? Okay, so alright. Then we go to, let's try one lady, Alia Husna.
Sir, saya punya tadi problem sama dengan low chemokoi. Lepas tu saya
Okay.
reinstall balik.
It should be done last week. Okay. Not good. Right.
Sorry sir?
This is not good, right? Because I've told you guys to install it last week. It's not this week. You guys just start to do the installation, right? I mean, if you guys face the error last week, right, then you have to tell me. Then I'm gonna help you guys to solve the issue. If you're waiting for the lab, I mean, in this lab, we are going to do another lab, which is lab 2, right? So, I mean, like, guys, come on. I don't want this kind of attitude, right? Okay, let's try another one. Chan Tian Tian.
Yes, sir.
Okay, go ahead, share your screen.
Wait. Take a while, sir.
Right. Guys, my advice is general. I'm not pointing to just Ahmad Nazrin and Alia Husna. I mean, for the rest of you guys, right? You should have come prepared to the lab. I mean, this is not the kind of attitude that we are expecting from a student, right? So you have to be ready, right? You know the lab session, we already told you, I've already provided the link to the software, whatsoever, right? So you guys have to be ready. I mean, we already put an effort. You guys need to put an effort too. Right? Procrastination is not good, right? You guys keep on delaying to do your work until when the time is due, then I mean, like, it's not gonna be good for you guys. Right? Sorry for the morning lecture, but I think I have to let you guys know, right, about this. All right, go ahead. Have you compiled it, Tian Tian?
Yes.
You okay? I mean, if you
I use Cyclone 2 for this software.
okay, all right, okay, that's a good thing, right? So, okay, when you show me the screen, at least we can have some discussion, right? And then you know, uh, what to do and whatsoever. Okay, like right now, so it's okay to use whatever family, right? You can use Cyclone 2, you can use Cyclone 4, because right now we are not targeting the real board, right? So we are not going to load our program into the real board. So we just want to look into simulation, right? So any family that works is fine, all right?
Okay.
Okay. And then for the compilation, once you already compile, right? If you want to show, if you want to demo, you don't have to recompile.
Oh, okay.
Okay, because why 10 because later if you go into industry, you're not gonna work into like just 5 or 10 lines of code, right?
Yeah.
So it gonna involve like, you know, thousand of
Take longer
code, and then
time.
yeah, it gonna take longer time, right?
Okay.
So but right now it's okay because it's short code.
So
Okay, go
if
ahead.
I don't want to compile again, I should press this one also.
No, yeah, if you don't have, I mean, you need to compile only if you change the code, right? Yeah, because all the changes will reflect after the compilation,
Okay.
right? Okay, so have you tried the simulation?
Yeah, so far no problem for this.
Okay, can you show me how you simulate? Because I mean, when you show me, of course, other people will learn too, right? No, it's not project wizard. No, okay. Okay.
So actually
Okay.
it's just like either I want to key in whatever I want, is it?
That's right. That's right. But okay. Basically, okay, for the simulation, right? You have to know how the circuit works because this is your design, right? So I'm giving you an example. Let's say you construct an AND gate, right? AND gate. So AND gate, if 1 and 0, what's the output of AND gate?
0,
Yeah, 1 and 0, the output is 0. If it is 1 and 1, then the output is
1.
1. Alright, so you know how the output is. Okay, then that's why during the simulation you just try to give all possible inputs. Yeah, for example, if you have 2 inputs, it's going to start with 0 0 0 1 1 0 and
1, 1.
1 1. Yeah, then you look at the output. Try to verify whether the output is correct or not. Right? Try to do it.
Okay.
Okay, next in line to present is Ihsan Mirza.
Okay, sir.
Okay. Ihsan Mirza. You're live. Ihsan Mirza.
Yes, sir. Yes, sir.
Okay. Go ahead, share your screen. I'm recording, right? So I'm taking all the names that I've presented, and you guys, I mean the one that already presented and can show something like 10, you are good for now. For the rest of you that I've called the name but hasn't presented anything yet, I'm gonna call again your name to make sure that you guys have done something. Right, go ahead, Ishan.
Hello, sir. Can you see my screen, sir?
Yes, you can see it.
What I've done so far was referring to the lab module.
Okay.
I've read the coding for the half adder,
Uh-huh.
full adder, and the 2-bit adder. So I had written down the whole coding in one file,
Okay.
and I have compiled. So far, it has shown that there is no error, but when I
Okay.
tried to view the circuit design,
All right.
I had to represent.
So you combine all the lab in one file, right, Isan?
Yes, sir.
Okay.
All the coding for the half adder, full adder, and the 2-bit adder in one file.
Okay. Hey, where's your screen sharing?
Sorry, I was sharing just a window. I need to share.
Okay.
Yeah. So, can you see this?
Yeah, I can see it.
So I had opened up the viewer to see the circuit, and it only shows me the half adder.
Okay. All right. Okay. What happened here, Isan, is that uh you you cannot have. I'm not sure, but it's not giving error, right? I mean, it's a good practice. You cannot have multiple module in one file.
I see.
Okay. All right. So your option is that is to do what I've explained before. So separate each module in one file, right?
Yes.
So every time you want to compile it, so you just remove the file that you don't want. So only leave one file, then you compile that one.
I see.
Or you can go with another options, you can create multiple projects. So each module gonna consist of one project.
I see.
Okay. All right. So have you tried to do the simulation, Isan?
I have tried, but
Oh.
uh, hang on.
Okay.
So I have taken the input and all, but when I try to do a functional simulation, it tells me the error, and I'm not sure how to troubleshoot. It says here errors occurred during model simulation.
All right. Just that. Okay. I think because of the confusion caused by your code, by your coding. So
Mhm.
try to do as what I've said. So then try to simulate again. Okay.
Okay, sir.
All right. That's good, Isan. Thank you.
Okay, thank you, sir.
All right, so let's pick another one. Right, okay, who gonna be the lucky one? Right, let's go to the name. Or anybody wants to volunteer? No, right? Of course, no. Okay, wait, Farisha. I know. Okay, how to know which one is submodule or top? Okay, all right. Later, I'm gonna tell you about this. All right, so who gonna be the lucky one? Alright, so Yankee, Chu Yankee. Are you there? Chu Yankee? Hello, Chu Yankee.
Hello.
Okay, alright. Are you ready? You can share
I
your
have
screen.
a problem with the same with the Ilsan one. My one.
Okay, alright. So you have problems here with assign?
Yeah, the simulation one got error.
Alright. Okay. Okay, alright. Thank you, Yankee. So let's pick another one. Daniel Liu Yongzin.
Hi sir.
Hi.
Wait. I how to say?
Okay.
This is how I do my code lah.
Alright.
But when I try to wait,
What should I call you? Daniel, is it? Or Yongzin?
yeah,
Which one should I call you? Daniel,
Daniel.
or Daniel? Okay, right. Daniel, can you show me the previous one, the main window for the quarters?
Yes.
Okay, all right. Okay. Wait. Okay, all right. So this one, did you modify the code or you got it from somewhere else? Is it from the example?
Yeah.
It is from the
But
example,
I
right?
do it like yeah.
Okay, all right.
One.
Okay. All right, okay. This is good because I want to answer a question from, who's that? Farisha. All right, so Farisha, if you look at Daniel's screen right now, so look on the left side on the entity, right? Project Navigator. Look on the entity. Right, so you can see the top one, add 2bit.v, right? So if you see under add 2bit, add underscore 2bit, so there's a like a, what do you call it, downward error, right? And then there's another two files, which is add half one and add half two. Okay, so if you guys look here, then you know, right? So you know which one is the top level module file. So the top level module file is that add 2bit.v. Because why? Because all those two, when you after, I mean, this will happen after you compile it. Before you compile, you won't see this, right? So I mean, when you see, when after you compile it, then all these two files will sit under the top level module file. Okay, why? Because you look into this, the file there at 2bit.v, so you can see all the connections, right? So it connect with all the other modules. So look on the code here. So look on the code, and then line 10 and line 11, you can see at half, A1, and then all these things. So these are how you're gonna do the connections. So I will explain it when the time comes, but this is one good example how you can know that which one is the top level module. All right, okay, go ahead, Daniel.
Uh, I I after I finish this codes, I don't know how to stimulate the waveform.
Okay, all right. So how to simulate the waveform? I've shown in the example in the lab one.
Yeah, but for this case, since it has top and sub one, I'm quite confusing with.
It's okay. It doesn't matter how the file is, right? But the simulation is functional simulation. So you give whatever. It's still acting like half adder. So you should expect the output of a half adder, right? So you
Okay,
just give any inputs, right? So you're gonna see the output, right?
okay,
Okay.
okay. Thank you, sir.
All right. Okay, thank you. Okay, guys. So I think that's it for the presentation. So I'll do this every week, right, until the end of the semester. Why? Not to punish, not to to make shame of you guys. It's okay, guys, because I think you guys know each other, right? So I just want you guys to be ready, because I found out if I don't do like this, so some of you gonna take it for granted. You guys will come not prepared. Just wait for your friends to do it. Then try to get the codes from your friends. So this time you guys might be lucky because your name has not been called, right? So, but for the next week, be ready, because I've recorded all the names that I've called, and I know who are the one that I haven't called yet. Right. Okay, guys. So, any question before I go into showing you guys for the lab 2?
Sir,
Yeah.
I have a question.
Yes.
I've done the half adder before.
Yes. Go ahead, Krotoy.
Okay, and then bila nak buka balik hari ni macam cannot.
Okay. Sorry, guys. There's some disturbance. Wait. Okay. Okay. So your question is that you have created a project before, right?
Yeah.
Then will you try to reopen it? You got error? Okay. Can you share your screen?
Okay.
All right. All right. I can see your screen now.
Dia naik macam ni, sir. Sir?
Sorry, wait. Okay, wait. Full compilation was not successful. Okay, click on the introduction lab.
Introduction.
Sorry. Okay, no. Go down there, right? So there's a message. Okay, try to scroll up. I want to see what the error message is.
This one.
Yep. Yeah, you can scroll up.
Ini yang paling atas.
Try to double click on
Press the error message.
Yeah, press the error message.
Oh.
Double click on it. Nothing.
Dah double click dah.
The small icon one.
This one.
Oh no, the icon there. There's a after next to triangle, right? There's a circle. Circle X. No, that one, yeah. Click that one, yeah. That one is all. Okay, scroll down, scroll down. No, just click the X, the circle X one. Yep. Okay, nothing happened. Okay, try to show me your code there. Tadi apa, your friend said try to click the flow message. Which one, Farisha?
Dekat compilation report tu, cuba tekan. Ada dekat tab tu. Tab yang kat coding tu, tekan compilation report tu. Christina, dekat tab tu, tab atas. Nampak tak? Sebelah introduction lab tu.
Ni ke?
Tekan, nampak tak flow message tu, dia macam tertutup sikit dekat tab tepi. Dekat ni ada tulis flow kan, cuba tekan flow message tu.
Yang ni ke?
Ni flow messages, tekan.
Okay, alright, okay, that's good. Alright, okay, so see that top level design entity introduction lab is undefined. Okay, so what I've told you guys, so try to open your introduction lab 1, Novi.
Oh, this one.
Yeah. So the top level module name has to be the same with your project name, because this is your top level module. Yeah, I mean capital should follow.
Oh, okay.
Alright, okay.
Saya nak juga.
Open the introduction lab 1.v. The I, right? I is capital. But the name is the project name is not capital, the I. Okay, alright, so problem solved. Alright, any other question, guys, before I start to present that too? Alright, thank you, Christina. You can stop sharing. Alright. Okay, any other question? Okay, so if no question, then let's go to lab 2. Let me share my screen. Alright. Okay, can you guys see my screen right now? Guys, can you see my screen? Okay, alright, good. Okay, so right, okay, this is which one is lab 2? So this is lab 2, right? So lab 2 is regarding the memory. Of course, there's an exercise that you guys have to do. Then I'm gonna check it next week, right? So this is the code for the memory, right? Okay, basically, let me explain about memory a bit, because this is kind of jumping to the front of the syllabus. We are ahead of the syllabus, but it's okay. This is, I think, basic thing that you have already learned before. But right now, we try to do the simulation, right? So if you guys remember, there are two types of memory, right? Volatile and non-volatile. What's the difference between volatile and non-volatile? Non-volatile. Anybody wants to take a guess? I think you know it, right? So, guys, what's the difference between volatile and non-volatile?
Volatile mean the short-term memory. For non-volatile, is a long-term memory.
Okay, all right. You can describe it in that way too. Right, so basically volatile is that when you power off, right? Example, your laptop, right? So, okay, yeah. So volatile memory does not store it if there's no power. If you turn off your laptop, turn off your PC, all the memory, all the data inside the memory will be gone, right? But for non-volatile, right? For non-volatile, I mean, like if there's no power, the data will remain, right? So data remain even there is no power. When no power, right? So example, what is the example of non-volatile? You guys are having it around you, right? Okay, no, I mean like you want, yeah, ROM is one thing, yeah, your hard disk, right? So ROM is read only memory, yeah, your CD, right, your pen drive, yeah, correct. So these are all the non-volatile memory devices that you have around you. So whenever you take off the power, all the data will remain. So that's why if you guys watch in a movie, right, when like a spy movie, right? So when they they want to get the data, right? So even though you already deleted some things in your hard disk, but they still can trace it, right? Because the way they are writing on the memory, they are making permanent hole on it. So even though you have erased it, right? But the data still can be traceable. So that's why if you watch in the movie, what they do is that they're gonna take the hard disk. How they gonna destroy it? They put it in a microwave oven, right? Then it's gonna burn the hard disk. So it will cause permanent damage on it. Then the data cannot be retraced anymore. That's just the side story. So that to make this more interesting, right? So basically there are two types of memory, volatile and non-volatile. So for volatile is like your RAM, right? What is RAM? Right, so RAM is a temporary place where you're going to store your file to do the processing. That is why if you have a laptop, then you realize, right, when you open Quarters or any heavy, that require heavy processing power, so your laptop will start to slow down, hang. Because why? Because the RAM, right? So the space that they have to work is small. So they have to take turn, right? So that is RAM. So that's why normally RAM, it is volatile. It just store when they have power. Why? Because RAM is one of the fastest speed memory. For an example, hard disk, right? Hard disk, the HDD one, the one that's using optical is kind of slow because there's a rotating device in it. But for the SSD, now they use chip for it. So that's why you can have a faster memory. But the fastest one, of course, one of the fastest one is your RAM itself, right? So that's why RAM is expensive. Then they put it very near to the processor. Normally you're going to slot in your RAM on the special slot, right, on the motherboard, and they have a special connection direct to the processor. All right, so that's memory. All right, okay. Now today we want to do a lab simulation. We are going to try to emulate the main memory or RAM, right? So if you guys look into the code, so just copy and paste it. It will run perfectly, right? So the module name I put here is lab 2. So remember, like the top level module, the first, if this is the only file that you have in the project, of course it's going to be your top level module file. Right, then you have input clock, and then you have memory access address. Right, okay. Yes. talk to the basic of memory. Okay, let's say this is your memory location. Alright, imagine like this is a building, right? Apartment. So you have level. I mean, this is the highest level, right? Second highest level, third highest level, right? And it goes on and on. So at each of these house level storage, right? You can store your data. You can store your stuff. Example here, you want to store your Louis Vuitton bags, right? So down here, you want to store all your expensive watches. Right? Just imagine you get somebody donate to your bank account, right? 4 billion. So you want to store all your stuff, right? So you have a lot of compartment. So same thing with the memory, right? So you have a lot of storage area here, and each storage can contain some amount of data. So it's depend on the memory specification. So in our case here, example here, so we are designing a storage area that can store 0 to 15, which means that if you count 0 to 15, you're going to have 16 bits of data. So each location here, you can store 16 bits of data. All right, so I mean, of course, you cannot exceed it because this is the amount of storage that you have set in the design, right? So each location can store 16 bits. But then how you can differentiate, right? Each area here, so you have to give address. So this is house number 0, this is house number 1, this is house number 2, and it goes on until whatever number that you have, the maximum amount of buildings or house that you have to store your data. Right, so that's why you need to have the memory access address so that you know to choose which house, which location that you want to go. Either you want to go and pick something from house number 0, or you want to go something to go to house number 1 and pick something from it, right? So that's why you need to have the memory access address. And memory write data is the line, right? What the line that we supply what you want to put in it, right? So let's say this you want to store like number 00001 inside here, so you can use this memory write data, whatever data that you want to put inside each location. And then they have the memory write enable. This is the line where you want to tell, right, whether you want to do the read or write. Right, so if you want to write, then you have to enable memory write. If you don't want to write and you want to read, then the write shouldn't be enabled. You should enable the memory read. Right, so and then this is just the output part. So later I'm going to show you guys inside the simulation how it is. Right, but basically from here you can draw a diagram, right? So you can draw a diagram of the memory. So let's say this is your RAM, right? This is your RAM, and then you have your mem access address. So this is your mem. Now I'm not gonna write in full. All right, so access address. So the size is 16 bit. Then you have mem write data, and then this is also input. So input, and you have mem write data, mem write data, and this is also 16 bit. Then while add what else we have? So you have mem write enable. So you have mem write enable. Okay, this is only one, so you don't have to write anything. And then mem read. So you have mem read. Mem read. So you have 4 inputs, 9, and then you have one output, only one output here, right? So one output, mem read data. So mem read data. So the size of memory data is 16 bits. Right, so this is how the diagram of your RAM looks like. All right, so what is this? So here is you just want to create an integer within your code. So why you need an integer? Because there's a loop here. Of course, you've learned C programming, right? So you can create integer. So this is just for the usage within the code only, right? So you create an integer, and then you create a register where the size of the register is 0 to 15, which is 16 bits, but you have 0 to 255, means that you have 256 of locations, right? So what does it mean here? So, right, what does it mean here is that, okay, let's go back here. Okay, so register 15 to 0 means that the size of the memory that we create is 16 bits, because 0 to 15 is 16, right? And then how many locations we have? So we have up until 0 until 255 is 256 locations. This is total, right? But if you go from 0 and then the maximum here, the bottom is 255. If you guys have any question, just ask me, right? If you're confused on what I've tried to explain, then just let me know. Okay, all right. So that is this part. Okay, here. All right. So here in this part is kind of tricky here. So what we are doing here. Okay, if you guys look down here, all of the read and write will use RAM address. Right. So what it does is that here you are taking the bit 1 until bit 8 of the memory access address, and you assign it. You pass the value. Okay. Okay, let's say you have here wire, right? So wire. So you have wire, you have 8 bits of wire. So 1, 2, 3, 4, 5, 6, 7, 8. And then here is wire 0. So wire 0 until this is wire 0, right? The first one, and it goes until wire 7, because you have 8 wires. Wire 7. So each wire can carry 1 data. And then you have mem access address. Okay, you look here, mem access address, you have 16, right? Okay, you have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right, so this is your mem. I just make it short form, right? So mem read data 0, and then here is mem. Oops. So M R D 15, right? Because you have 16 bit. Okay, what you are doing here? So what you are doing here is that you are connecting bit 1 to bit 0, bit 2 to bit 1 until bit 8 to bit 7. So you are taking, so here is 0, right? So you are taking from 1. 1, you are connecting it to wire 0. And then mem read data 2, you connect it to wire 1. So until 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6, 7, 8, until this one, right? So this is mem read data 8, you connect it to wire 7. So this is what happening on the line here. Maybe you don't understand right now, so as you go through it, then try to refer to this recording again, right? Then you'll get it, right? Okay, so what does this part do, right? So this part is just initializing, right? So you see here for I equal to 0, I maximum is 256, then I equal to I plus 1. So because this is RAM, right? So every time you want to use it, you want to clear, right? You want to set all the value to 0. Right, so you don't want any value left before you use it. So when after in the beginning, so initially So you'll try to erase and set all the memory location, the data to 0. Okay, now we start the process. Okay, always every time at the positive edge of the clock. Okay, this is clock, right? I'll show you guys later how we can set the clock. Okay, I mean, this is our clock. So here is the positive edge, right? So here is the positive edge as it goes from 0 to high. And then here is what they call as negative edge. It goes from 1 to 0. Okay, what is the code is telling here? So always when the clock is at the positive edge, then begin. Okay, then you do the process, right? So you check if the memory write enable, which means that if the memory write enable is equal to 1, then you do this, right? So whatever the write data that you give, you put it inside the location of the RAM, right? Then if not, okay, so assign memory data. If, okay, this is another way of assignment, right? Okay, what is doing here? Okay, now assign memory data. So the memory data, okay, check the value, right? So if if memory is equal to 1, okay, if the memory is equal to 1, right, then you see the question symbol here, then you assign the whatever data that you pick up from the location to the memory data you pass out, right? So this is when you want to read it. So what happened when you want to read it? You go to the location, right? You pick up the data, you send it to the output, right? So what the code is doing here, so if the memory means that you are giving the memory signal, you want to read from the memory, so you give the signal equal to 1. If the signal equal to 1, then you're going to take the data from the location, you pass it to the output line, right? If the memory read is equal to 0, then you just set the value as 0, right? Okay, it's okay. This is the code part. Of course, you have to relate, right, between the code and also your simulation. But the most important thing is that you have to understand whatever the code is. Okay, let's look into the simulation. Okay, now let's see and on how I set the input, right? Okay, guys, this is how I set the input. Okay, the first one, you want to set the clock, right? So how to set the clock? So select entire interval, right? So then right click again, go to value, right? So go to value, then you choose override clock, right? So you can do whatever period that you want, it doesn't matter. But later when you work on the real project, you have to check what is the clock source and whatsoever. But here we can put anything because we just want to see the functionality of our circuit, right? Okay, then here you select whichever part that you want to assign the value, right? And then after you select, okay, let's say I select here. Then you right click, you go to value. Go to value, then you choose arbitrary value. Right? You can choose set whatever input that you want to give. So this is for the memory access address. So you guys see here for the memory access address, I start with 0010, right? And then 0100. Why? Because of the assignment. Because of the assignment here. Yeah, this one. Right, so I have to skip bit 0, right? Because all the counting will start from bit 1. Right, so I have to skip bit 0. Okay, right, so then okay, here if you see here, so this is the data that I want to write into the memory. So what you see here, so here the value that I've set in hexa, right? So you can set the radix. So you can view it. Example, you want to view it in binary, right? So, but to make my life easy, so I just view it in hexadecimal. Also here, if you want to make the memory address, you want to view it in hexa, it's up to you. Right? So if you want to view it in binary, you can also can, right? So okay, then okay, here I want to write to the memory, so I enable the memory write. So I enable the memory write here, and then on the next part here, so I want to read from it. So I want to check all the data that I've written to the memory is available, right? So then I disable the memory write, and then I enable the memory read, right? So then after I've completed, I press run the simulation, and here's what I've got. Right, so as you can see here, I mean, here is the part where they store the data to the memory, the RAM, and here is where I call the data that I've wrote inside the memory. As you can see here, right, 002, 3, and then also 4. Okay, guys, so basically that's all for Lab 2. We are designing a memory by using a verilog code, right? So why we are doing this? Because memory is part of computer, right? So this is a part of program that finally we going to integrate, right, with ALU until we form a basic computer, right? Because you guys are learning the computer architecture. So that's why we try to emulate these things so that you understand how this computer works, right? At least basic at the fundamental level, and you can know which one that cause you a problem, something like that. All right. Okay, guys. So any question regarding lab 2? Any question? Are you guys there? Or I'm just alone here?
Hello, sir.
Yeah, hi.
I don't understand the last second line of the code.
Okay, that's second line of the code. This one?
Yes.
Okay, all right. Okay. All right, so it's like this. What's your name? Shinwen? Shinwen, okay. Right, so Shinwen, it's like this. All right, so now we want to assign the data to the output, right? So this is our memory here. Okay, this is our memory, right? So this is our output. So we have to choose, let's say we have a lot of location in our RAM, right? So a lot of location. So we have to choose which location that we want to connect, right, to our output. So we can only connect only one location at one time with the output. Okay, what they are doing is, so this is your output, right? Okay, but it's depend on the memory. So memory signal, right? So memory signal, if you look into here, so this is okay, here's your memory. So the memory determine, right? Is telling the memory that you want to read from it. So if you see here, I mean, I still have the address, right? But when my memory is 0, so the output is 0. Okay. So, okay, let's say now it's checking the condition, because this is how a sign syntax is working. Right, so memory. So if the memory is equal to 1, then you pass whatever value. So let's say your RAM address you are referring to 0, right? So RAM location 0, you pass it to memory data. Right? So okay. So if it's 1, if it is 0, it won't take this part of the code. If it is 0, it's gonna take this part of the code. It's gonna give you 0. It's going to assign 0 value to memory data. That's what you see here. When it's 1, it's go and take your address, right? And then go fetch the value 4 and then put it here. But when it is 0, although the location is there, is gonna give you 0, right? So here is the condition, right? So they're gonna check the condition here. Then the question after the question mark is the option. So option number 1, if it's 1, then you take the value from the address location. If it is 0, then you assign the value to 0.
Oh,
Okay.
okay. Thank you, sir.
All right, Shanlai. That's a good question, guys. All right. Any other question? Sir, for why? Okay. All right. Okay, that's good. At least somebody asking about it, right? Okay, so I also think, why? Because this code, of course, I got it from internet, right? Okay, why they design this such a way, right? Because I'm thinking because this is a memory design, right? So once you do the memory design, so normally if you look on your RAM chip, right? If you look on your RAM, they have a multiple memory chip on it. So that's why you see sometimes they have 4, sometimes they have 8 of chips on your memory stick, memory RAM stick. So why is that? Because the capacity of the memory, right? One chip might contain 256, but if you want to add more, right? So you have to have a multiple number of chip to construct the RAM. So here is one of the way that you can have multiple RAM module, right? And then what they can do is that the LSB, the least significant bit, will be the one to be used to choose, right? To choose the number of chips. So let's say, for example, you only have one here, right? So bit number 0, right? So you can only have 2 chips. So if the LSB, the least significant bit, the bit 0 is equal to 0, then you are referring to address of the chip number 0. If the LSB is equal to 1, then you are referring to the chip number 1. You can change this code, I don't want to tell you, but you can figure out. If you don't need this, you can change it to make your life easy, right? You can start from the LSB. Doesn't matter if you change it, right? So as long as it works, then it should be fine, right? But why they design it this way? Because they want to support multiple RAM module, right? Just the answer for your question. Okay, guys. So any other questions?
Sir,
Yep.
can back to the waveform.
Okay. Waveform. All right. Waveform.
So, you say that this is a positive trigger, right? I think it's like the negative trigger instead of the positive trigger.
Yes, correct.
So I want to change the positive trigger. So how we set up this?
Okay, all right. So sorry, come again. What's your question? Kim Ho, is it?
Yes.
What's your question again?
So we look at the waveform. So it's a negative trigger, right?
Okay, all right, okay. That's a good question. Okay, from here, right? So okay, all right. If you guys look in the code, right? Okay, you guys look in the code. The one that is positive edge triggered is only this part, where this part is only writing part. So but the writing part, you cannot see exactly where does it activated, because we don't have any output showing that the data being stored into the memory, right? So you guys are not really seeing that it's a positive edge triggered. But here at the output part, right? So you look at the output part. So the output part is already outside of the always. So assign. So how does assign work? Assign works every time, right? Every time. So either it's a positive edge or negative edge. Whenever the memory read is equal to 1 or 0, then you change it. So that's why if you see here, so I change the value at the negative edge here, right? So whenever they found out the membrane is 1, so automatically it's going to update the value. Same goes here. Right, so you can try to change, play around, right, to make it at the positive edge. You're going to see it just going to follow. Because why? Because a sign, it does not depend on the clock. Right? It's just do what do you call it? It's take effect immediately based on the input. Right? Are you following me, Kim?
Yes, sir.
Okay, guys, any more questions? Okay, all right. So if there's no question, I'm gonna stop the recording first.